Hey, philosophy class. So I got an email saying that the homework was a little incomprehensible, and I think the reason was probably because I didn't explain it too well what you were doing when you're doing proof theoretic validity. Um, so here's basically what you do. I think this is what I think we'll do. I'll go through maybe A and B, and then I'll let you guys do C, D, and E. So um, yeah, follow along, and hopefully this will make a lot more sense this time. Here's what you're doing with proof theoretic validity. You're taking premises and you're trying to prove the conclusion by saying, hey, if I assume the opposite of the conclusion, the not of the conclusion, right, then I come up with nothing but contradictions. And I can't have contradictions, they don't make any sense. So it must be the case that whenever I have these premises, I have this conclusion, right? So what you do with the, when we call the initial list, you start off by taking the premises, so if P then Q, if R then Q, and then you take the opposite of the conclusion. You take the not of the conclusion. Not the case that P or R then Q. Alright? So if I can make this make sense, right? If I can make the premises work with the opposite of the conclusion, well, I've shown that I don't necessarily need to have this conclusion when I have these premises. I might have the opposite of the conclusion, right? But if I show that every way that I apply these rules, every which way I do it, I come up with contradictions, then I've showed, hey, I can't work with this guy right here. I can't work with the negative of the conclusion. I need to, I have to have the conclusion when I have these premises, right? Now, what these rules are down here are pretty much the same thing that semantic validity taught us, right? A or B is true if either A is true or B is true. So we say, well, let's pretend A is true, what happens? Or let's pretend B is true, what happens? Now, when we're doing proof theoretic validity, we don't want to use words like true or false, but that's basically what you're doing. So, let's start applying some of the rules. The first one is I'm going to do is this one right here, the not if A then B. It's this rule right here, all right? And if I apply this rule, what I get is an A and a not B. Now the A here is the P or R, right? That's the first part of here. And the B here is the Q, the second part. So this says I have A, P or R, and B, not B, which is Q. And the reason this rule makes sense is because if A then B is false, the only way that it can be false is if you have A but you don't have B. That's what this statement says. If you have A, you have to have B, right? So if this is a false statement, then you have A but you don't have B, and that's why this rule makes sense. Now I'll apply. Now let's play the OR rule to get rid of this guy. Okay, the OR rule says at least one of these two things are true, right? So I can't put them all in the same branch because I don't know if both of them are true. I'm saying at least one is true. So we'll put them on different branches. P will go in this branch and R will go in that branch, right? So now we have two possibilities. Either P is true or R is true. Now, I don't care about that both P and R are true because I don't really need to worry about that, right? That's not something, if P is also true, then great. But based on this statement, I'm just saying at least one is true. That's the only thing I get from them. Now, I haven't been doing this, but I told you that you put little checks by there so you know that you've applied that rule. Now let's apply this rule we're applying to both of these guys right here, okay? So the first one is if P then Q. Now again, if P then Q is true if either the first part is false or the second part is true, right? So, and that's something, if you don't understand what that is very tricky. That was when we did the little circles, right? And we had if P then Q. If P then Q means that you can't be in P without being in Q, but the rest of these are okay. If you are in P and you're in Q, you're good. If you're in Q but you're not in P, no big deal. If you're not in either one, no problem at all, right? So this statement, if P then Q, is true if either you're not in P, right, because all the things outside of P are good, or if you are in Q because all the things in Q are good. The only part that's not good is being in P but not being Q, right, which was this one. So we're applying this rule, and we'll apply it to the first one first, not P Q. Now I have to do it to both sides because remember we said here's one option, possibly P is true and possibly R is true. Well, if R is true, I need to know if this works too, right? So I get the same thing, not P and Q. And I put my check because I'm done with that guy. And now I'm going to look down here and I see P and not P. So here's what that means, right? In this guy right here, one of my options are P being true, right? And if P is true, and from here not P is true, now I have a contradiction. That can't work, right? And from here I know not Q is true, and if from here the fact that Q is true, then I have not Q and Q being true. That can't work either, right? I'm saying Q is both true and false. That doesn't make any sense, right? So this whole branch doesn't make sense. Good, so I've got that one knocked out. Here I have not Q and Q. That doesn't make sense, so that one's out. The only one I have left standing is not P, but I still have this guy that I haven't applied. So let's apply that one. Same rule, right, which is this one right here. Same rule to R if R then Q. If R then Q is true, if either not R is true or if Q is true. If not R is true, then from here we're on the R branch, right? We're on the branch where we assume that R was true. Oh, but that doesn't make sense with not R, right? You can't say R and not R. That doesn't make any sense. Also here on this branch, I have not Q and Q. So that's a contradiction too. Now, all of my possibilities have led me to contradictions. So I know every time I have these two premises, if I take the opposite of my conclusion over here, then I'm left with nothing but contradictions. So I can't take the opposite of my conclusion here. That doesn't make any sense. So the only thing that makes sense if I have these two premises is to say every single time I have to have the conclusion, right? So these two premises entail this conclusion. That's what we've proven here by showing that if you take the opposite of the conclusion, you're left with nothing but contradiction. Alright, I'll do one more and then I'll let you guys do the rest by yourselves unless you have big problems. But it's getting kind of late on Sunday night, so I'm not sure if I can do much more. If P, then Q and R. Let's do that one. If P, then Q and R. That's my first premise of the second problem. The second premise is not R. And my conclusion is not P. So I'm not going to use not P here. I'm going to go not P. Right? Not this thing right here. Because again, what I'm trying to prove is if I say this is a false conclusion, if I have these premises, can I ever have this conclusion be false? Can I ever have this conclusion be wrong? If I can, if it makes sense to say that sometime it's false, then this doesn't prove this. But if at no time does it make sense to say that the conclusion is false, then these two do prove this. Alright, so the first, easiest one is the not, right? The not P, based on this rule, is just P. So I'll check that guy off. Not R is a basic proposition. You don't have any rule down here because it's as small as it can get. Then you have this rule, if P, then Q and R. So that's this right here, right? So I will go this way with a not P. And the B, so that's A here is P, and B here is Q and R. So I'll go over here, Q and R. And I'll check that guy because I'm done. Oh, I have a P and not P here. That doesn't make sense. So I'll cross that off. I have an R and not R over here, so that doesn't make sense. So I'll cross that one off. Now, oh, sorry. Shoot, that's not right. That's not right. I didn't mean to do that. First, I have to break these apart. First, I have to apply the rule. So Q and R is right here. Here's the rule. So yeah, that wouldn't have worked at all. So I have to get it down like this. Q, R, right? So here I have not R and R. That's a contradiction. So once again, I see where the not P, if I say not this conclusion, then I'm left with nothing but contradictions. So it doesn't make any sense. So I have to have this conclusion. Now let me just quickly walk you through this in probably terms that will make a little bit more sense maybe than this. So why is this all true? Well, look at this statement. It says, if P, then you have both of these guys, both Q and R. And this is saying that you don't have R, right? So if you don't have R, then you don't have both of these, right? So and you don't have both of these. This statement right here said if you have P, then you have both of these, but you don't have both of these, so you don't have P, right? So not P, which is the conclusion, right? So this should prove the conclusion anyway. So that should make sense anyway. All right, please email me if you have any other questions, and if not, I will see you on Monday.